Hello dear students, very good evening to all of you guys and welcome back again on Wallah English YouTube channel guys. So we have already completed the 6 lectures, right, which is related to the structure part, right, and our today's session is basically based upon the truss again guys, but this particular topic is most important for the gate examination. Like you may find like a 1 mark question from related to this particular part, right, or this particular concept. So that's why we need to understand what is this exactly and how we can solve the problem which is related to such type of concept which is known as null force member or zero force member. So our today topic is basically understanding the zero or null force member. Basically we need to understand what do you mean by null force or zero force member and how we can find in the truss without doing the complete analysis. Like you don't have to do the complete analysis like method of joint or method of section. You don't have to apply that. You need to understand such means simple basic concept so that you can predict how many number of zero force member are there in the truss, right? So that's why this topic is important. Okay guys, so you know that guys, our today session is basically based upon zero force member or null force member. In yesterday class we have discussed the lot of problem which is related to the method of joint and method of section, which is based upon the determinate truss part. So this particular thing we have already completed. Hi, come fast guys, come fast. Good evening. Come fast guys and join the session. Okay, and if you find any difficulty while discussing anything guys in this particular lecture, please let me know. I will help you definitely. Okay, so let's start our session. There is one more information guys which I want to share with you. You know that guys, we have already done the ranker test 101, right? Ranker test 1 is already completed. Now you have another opportunity to join our ranker clubs, right, by giving the ranker test 2, which is on 8th of September. You can join it guys on 8th of September. You can see here from 10 AM onwards you are able to give this particular test. Now what is this? This is basically a free test which you can give and you can join our ranker community, right? We have a community where we will give you some mentorship, we will help you so that you can achieve little bit more, right? So guys, this is basically our syllabus of our ranker test 2, in which you have to give means you have to solve the problem of engineering mathematics general aptitude. In the technical subject we have 2 subjects basically. One is geotech and second is highway engineering, right? So basically you can see here guys, let me reduce the size of it. Okay, let me bring in this way. So guys, what happened in this particular test, what you will find, there are 26 questions and it is of 40 marks, right, and 72 minutes. The duration is 72 minutes. So guys, you have to give this particular test if you want to join our ranker club, right, where you will get the guidance of the way for your problems while you having some preparation. Means you may find some difficulty in the preparation duration also, right? So if you are eligible or if you get a well score, then definitely you can get our mentorship also, right? Okay guys, so let's move to the next thing. This is our Telegram channel, means my Telegram channel guys, where you can join and you can get the PDF as well as the link of the lectures also. Okay, so you can join this. And let me write, sometimes student may ask also, sir, please write the complete name of the Telegram channel. So guys, you can search this Krishna Yadav sir PW, Krishna Yadav sir PW. You can search this on the Telegram. You will get my Telegram channel where you will find the PDF as well as the lectures link, as well as guys you can ask me any doubt also. Okay, so let's start this particular session. Okay, you know that guys, we have already done 6 lecture. Let me show you that what are the lecture we have already completed so that you can understand right now where we are standing. Okay, so first one is we have discussed the static indeterminacy. Second one is basically we have discussed the problems which is related to the static indeterminacy part. Third, we have completed the kinematic indeterminacy, as well as we have discussed the problem which is related to the decay value. Another thing which is basically the method of joint and method of section, this is already completed. And in yesterday class we have discussed about the problem of determinate truss, which is related to these method basically. Okay, now in today's session we are discussing the null force member, understanding zero force or null force member in the truss. We'll discuss the concept as well as the question part also. Okay. Okay, guys. Now, these are the statement. I think you know about it. But guys, I don't want to go into the statement part. I will explain the concept in detail. That is my main aim. So that each and every student can understand why such type of statement is to be used, so that we can make some zero force or null force are there in the truss member, right? So we'll discuss this particular point, right, in detail first, then we'll read this particular statement, what it is exactly, and then we will solve the problem. Okay, so let's start with the concept one. Basically, there are three concepts. Let me write here. There are basically three concepts by which you are able to get the zero force member or null force member. We'll discuss three concepts, not two concepts. We will discuss three concepts. We'll discuss three concepts which is useful to find out the zero force member or null force member in the truss. Okay, so let us start with the concept one. Listen very carefully, then only you can understand each and everything. Concept one. Concept one. Guys, let us suppose if you have a truss, and you need to find out how many null force member or how many zero force members are present in that particular truss. So what you need to do, you need to find out this particular condition where it is present. Okay, what condition, sir? I will discuss over here, or which type of concept I will discuss here first. Okay, so you just need to find out where you will find such type of concept or such type of condition which is occurring in the truss. If it is occurring, then it means this at that particular point, whatever member you have, they are basically zero force member. Okay, so let's understand. Let us suppose, guys, there are basically two members. There are basically two members which is present at a joint. Let us consider this is a truss joint. This is a joint, right, where two members are meeting together. Okay, and the angle between these two members is right now theta. So there is some condition for theta also. Theta cannot be equal to 0 degree. It cannot be equal to 180 degree. It cannot be equal to 0 degree. It cannot be equal to 180 degree. Okay, sir. If such condition will occur, that means if theta is equal to 0 or theta is equal to 180, that means the line of action of both the forces will be same. If it is same, then they will not be a zero force member. Okay, but why, sir? We'll discuss. So theta should lie in between 0 degree and 180 degree. It should be in between 0 to 180 degree. It should be in between 0 to 180 degree. And let us suppose this one is F1 force and this one is F2 force. This one is F1 force and this one is F2 force, which we have. Okay, sir. Now guys, what we will do, we'll write summation. Okay, let me add some more point over here, then we'll discuss the joint equilibrium equation. So right now this is one of the condition which should satisfy at this particular joint, and you can see here this theta cannot be equal to 0, it cannot be equal to 180, it should lie in between 0 to 180 degree. This is the first condition. Second condition, at this particular joint there should not be any kind of load or any kind of external support reaction. So no external loading or support reaction at this joint. At this particular joint, you do not have any kind of external loading or external support reaction, and the theta should lie in between 0 to 180 degree, right? If such condition will occur, then guys, we'll try to apply the joint equilibrium equation at this particular joint, and can I write summation Fy is equal to 0? That means F1 sine theta is equal to 0. Okay, sir. So F1 is equal to how much? F1 is equal to 0, sir. F1 is equal to how much? It is equal to 0, sir. Okay. Now what about F2? We can write here, guys, summation Fx is equal to 0. That means F2 plus F1 cos theta is equal to 0. So what is the value of F1? F1 is 0. What about F2? F2 is 0 again. That means both the member will carry 0 force, and both the member are null force member. Okay. If you find such type of condition in your truss, that means both the member, whether it is F1 or F2, are null force member or 0 force member. You can write it directly on your question without solving it. That's why we are writing it as a concept, right? Otherwise you can solve such type of joint also, guys, in our truss, but it will take a lot of time to get the correct answer or get the 0 force member. So to reduce the means our main task is to reduce the time and get the answer quickly, and that's why this particular condition is to be this particular condition or this particular concept is to be developed so that you can reduce your time and get the answer quickly. Okay, so this is one of the concept, guys. Wherever two members are there which are basically non-collinear in nature, if it is lie in between 0 to 180 degree, then in such condition it is non-collinear members. F1 and F2 are non-collinear. Non-collinear. Clear? And if it is non-collinear, then it means both the member are 0 force member. Clear? Okay. Let's understand the next thing or next concept. Let us understand the concept number 2. Concept 2. Let us suppose, guys, there are three members basically which are meeting at a joint. Let us suppose there are three members which is meeting at a joint like this. There are three members which is meeting at a joint like this. Okay, let us consider there are three members which is present at this particular joint, and this particular force is F1, this one is F2, this one is F3. Okay, and this particular angle is theta. Clear? Now, guys, again the same situation is there. First one is there should not be any kind of load or any kind of external support reaction at this particular joint. So we'll write here no external loading, no external loading or external support reaction. External support reaction. There should not be any kind of external loading or external support reaction. Okay, sir. Second thing is the angle between or the angle should lie in between 0 to 180 degree. If such condition will occur, then F3 will be a non-collinear member. F3 is non-collinear member. F3 is non-collinear member. Okay. What about F1 and F2? You can see here, guys, F1 and F2 is lying on a same line of action. That's why F1 and F2 are collinear in nature. Collinear member. F1 and F2 are collinear member basically. Okay, sir. Okay, sir. Okay, perfect. So we know that, guys, if such condition will lie, so definitely theta should not be equal to 0, theta should not be equal to 180 degree. It should not be equal to 0 or it should not be equal to 180 degree. Okay, sir. Now, guys, again we will use the joint equilibrium equation at this particular joint to get the answer. So what I will write, summation Fy is equal to 0. That means F3 sine theta is equal to 0. And if f3 sin theta is equal to 0, that means f3 is equal to how much? It is equal to 0. f3 is equal to how much? It is equal to 0, sir. f3 is 0. f3 is 0. Okay, sir. What about f1 and f2? Let's understand that. What about f1 and f2? Can I write it, guys? Summation fx is equal to 0. If summation fx is equal to 0, then we can write here f1 plus f2, sorry, f1 plus f3 cos theta minus f2 is equal to 0. And we know that f3 is how much, sir? f3 is 0. If it is 0, can I write it, guys? f1 is equal to f2. And if f1 is equal to f2, that means both the forces are equal and alike force. Both the forces are equal and alike force. What do you mean by equal? Equal in terms of magnitude. Alike means same nature. If one of them is tension, so other one is also in tension. If it is in compression, then second one is also in compression. That is the meaning of equal and alike. So these two forces are equal and alike force. Equal and alike force. F1 and F2 are equal and alike force. Clear, sir? Now let's understand the third concept. Let's understand the third concept. Concept third. Let us understand the third concept. What is this concept? Let's understand it, guys, in detail. Let us suppose this particular point we have already discussed in the yesterday class also, but let me give you a quick overview also, for this particular thing, so that you can remember it. Okay, guys, let us suppose, okay, let me write it in this way. Let us suppose if you have a truss like this, okay, and this is one of the joint which is basically connected by a pin support, and this one is also connected by a pin support. If it is pin support, so what will happen? We know that, guys, each and every truss joint will have two joint displacement, delta x and delta y, correct? So let me write here delta x, delta y. Similarly, this one is also delta x, this one is delta y, delta x and delta y. Now you know that, guys, due to the external support reaction, the value of delta x and delta y at the support will become 0. It will be 0, it will be 0, it will be 0. This one is also 0 and this one is also 0. What about this one? It is non-zero, right? Because there is no external support reaction which can stop this particular displacement value. Clear? Now that means if you have some external support reaction at this joint and at this joint, due to which the change in length of this particular member will be equal to how much? It is 0. If change in length is 0, we know that, guys, PL upon AE can be written as delta for the member in which only axial force is present. Okay. So can I say that if delta is 0, so what will be the force in this member? Again it is 0. Again it is 0. So please remember this condition also whenever you find a member in a truss which is connected by the support, right? Or you can say that the net change in length of that particular member is 0. If it is 0, then we will consider the force in that member is 0. Very simple. Crystal clear? I hope you are able to understand all three concepts which we have discussed till now. And let me show you the initial statement, right? And let me read it also so that you can understand whatever we have discussed in our concepts. So this is basically statement number 1. If only two non-collinear members form a truss joint and no external load or support reaction is applied to the joint, the two member must be zero force member. Okay, sir. If three members form a truss joint for which two of the member are collinear, the third one is zero force member provided no external force or support reaction is applied at the joint. So this is the condition. This is the condition which we have already discussed in our concept 1 and concept 2. I hope up to this you don't have any kind of doubt. Please write down, guys, if you have any doubt related to this particular part, anything you are not able to understand, please write down, guys. Anything. Okay, perfect. So let's move to the question part and let us solve it. Okay, let's move to the question part and let us solve it. So guys, this is one of the question which we have. Let's understand what we have to do over here. Listen, the figure below shows a pin jointed frame. What are the forces in the members BE? This is vertical member BE. Vertical member BE. Then CD. This is vertical member CD. Then we have ED. ED is basically a horizontal one, like this. Now it is understood, guys, you have 10 kilonewton load, which is exactly placed in between of this 2 point, or you can say that exactly middle of this AD length. Okay. So we know that, guys, we'll have one vertical reaction whose value should be 5 kilonewton, and this one is also 5 kilonewton. Correct? Okay. If 5 is applying upward at this particular joint, then 5 should apply downward at this particular joint. That means 5 kilonewton load should be applied like this. Now tell me, in CD member, what will be the force? 5. For CD, it should be 5. For CD, it should be 5. So this option we can eliminate easily. Okay, sir. What about ED member? Now you can see here, guys, at this particular joint, there is no horizontal force. That means horizontal reaction is equal to how much? It is 0. If it is 0, then this member will also be a 0 force member. So for ED, it should be 0. For ED, it should be 0. For ED, it should be 0. Now we have two options. It may be B, it may be D. Okay. We need to check the member BE also. We need to check member BE also. Right? How we can check it? It is very easy. Let me show you that, guys. Let us suppose this is a horizontal axis or horizontal line, and this particular angle is theta, and this one is also theta. Clear? And let us suppose the force in this member is FAB and this one is FBC. Okay, sir. So what we will do, guys, first of all, we will write summation Fx is equal to 0 at joint B. So what is this force? This is BC. So we'll write FBC cos theta minus FAB cos theta minus FAB cos theta, and it is equal to 0. Can I write FBC is equal to FAB? That means force in member AB and force in member BC is same. Okay, sir. Then we'll write summation Fy is equal to 0. If summation Fy is equal to 0, that means minus of FAB sine theta, then minus of FBE minus 10. Okay. Then we have plus FBC sine theta, and it is equal to how much? It is equal to 0. Now you know that, guys, this BC part and AB part is same. We can cancel this one and this one. So ultimately what you will get, FBE is equal to minus 10 kilonewton. Minus 10 kilonewton, right? So right now they are just asking the magnitude, not the sign, basically, right? So guys, which one is the correct answer? So for BE it should be 10. For BE it should be 10. That means B is the correct answer for this particular problem. For this particular problem. Crystal clear? Next question, which was asked in GATE 2004, and you need to find out the zero force member, how many it is present in this particular truss. Guys, you can see here, this is the truss where multiple joints are present, and there are some loading is also given, like P and Q is load, which is given with the respective joint. You can see here. You just need to find out the number of zero force member which is present in this particular truss. So right now, can you see this member and this member is collinear, this one is non-collinear. At this particular joint, there is no external support reaction. there is no external loading, so we can make this particular member as a zero force member. Correct? Now remove it. Remove this particular member for temporary purpose. After removing it, what you will see or what you will observe, this member and this member is collinear, this one is non-collinear, make it 0. Okay. If we come at this particular joint, now it is not possible to make zero force member further. Okay, at this particular joint, not possible. At this particular joint, not possible. At this particular joint, not possible because loading is given. At this particular joint, not possible. What about this one? Yes, make it 0. At this particular joint, yes, we can make it 0. Remove it. Now again 1, 2, 3 member are there, make it 0. 1, 2, 3, make it 0. Remove this. 1, 2, 3, make it 0. Remove this and this one. 1, 2 and 3, make it 0. Getting a point? Getting a point, guys? So how many zero force member you are able to see here? 8. Clear? Right? That means 8 zero force member are present in this particular truss. In this particular truss. 8 zero force member are there in this particular truss. Next one. Which of them is zero force member in the following truss? Again, you need to find out how many zero force members are there in this particular truss. So right now you can see here, guys, if we consider joint E, so ED member and EA member is zero force member, right? So we'll take here ED and A zero force, ED and A zero force, ED and A zero force, ED and A zero force. Okay. Next one is BD. BD is also zero force member because if you consider this particular joint, so these two member are collinear, this one is non-collinear, make it 0. Okay. So this one is zero force member and these are also zero force members. So BD is also 0. BD is also 0. BD is also 0. You can cancel this one. You can cancel this one. Now we need to check the member AC. Whether AC member will have zero force or it may contain certain force. So it is understood, guys. Now you are having only this particular triangle part or this particular truss portion. You can see here, guys. Now this is the only portion which is remaining in the truss. Like this. Getting a point? So right now you can see here, guys, 1, 2, 3. There are 3 external support reaction. You need to find it out. This particular value will be 0. No problem. No problem because this is an external reaction. No problem. But guys, you will get some or certain value of vertical reaction. After getting vertical reaction in this particular member, you may find certain forces there, as well as at this particular member also you may find certain forces present. Clear? So BC or AC cannot be zero force member. That's why C is the correct answer for this particular problem. Crystal clear? Any doubt? Any doubt? Done. Which of them is zero force member in the given truss? So guys, you need to tell me which one is zero force member. This is W, which is coming downward. So again, W is an upward direction. Then only this particular joint will get balance. So BD is not a zero force member. You can cancel it. What about CD and AD? We know that, guys, CD and AD will also have certain force. You can cancel. None is the correct answer. None is the correct answer for this particular question. Next one. Which of them is zero force member in the following truss? Again, you need to find out how many zero force members are there. Very easy. Listen, guys. If you consider joint D, then this member will have zero force and this member is also zero force because both are non-collinear in nature and there is no loading at this particular joint, no external support reaction at this particular joint. And due to that reason, these two member will be a zero force member. Okay. After removing these two members, what we are having, guys, our triangle or our truss will be like this. Getting a point? Now kindly check here, guys. You may find one horizontal reaction like this, and vertical reaction like this. Clear? Now please understand this. If you consider joint B, so what you will observe, AB member will also be a zero force member. If you take summation Fy is equal to 0, at joint B, you may find AB is zero force member. Okay. So AD is 0, CD is 0. AD and CD is 0. AD and CD is 0. Then AB is also 0. This is wrong. This is wrong. So B is the correct answer for this particular question. I hope all of you are able to understand very well how to solve zero force member. Next question, do it guys by yourself and please let me know the correct answer. I am giving you 1 minute. Please write down your answer in the chat box. Quickly guys. You need to tell me how many zero force member or which of the member are zero force member for this particular truss. Do it guys quickly. Which of the given member is having zero force? Zero force. Oh, sorry, not zero force. Which of the given member will be under in the axial load? It should not be zero. It should have certain force, right? It should have certain force. That means you need to find out non-zero force member. Clear? Do it guys quickly. Non-zero force members. Done? Okay. So first of all guys, we need to find out which of them are zero force member. Then we will find out which member will have certain force. Okay. So if you consider joint A, what you will observe, this member is zero force, this member is zero force. That means AB and AC is zero force member. AB and AC is zero force member. Okay, done. After that guys, our joint B will also show BC is 0 and BD is also 0. Okay sir, remove it. After removing this particular part, consider joint C. Again this one is 0, this one is 0. Remove it. After removing this one is 0, this one is 0. Okay. Okay sir. This one is 0 and this one is also 0. Okay, done. EF member is missing over here. You need to draw it like this. EF is also there. Okay. EF is also there like this. Now guys, we can remove those member from the option which have zero force. Okay. So you can see a DE is having zero force. So this option cannot be possible because it contains DE. Then EF, okay, EH, okay, EG is vertical, okay. Then FE, EH and EG. I think these two options are common, right? These two are common. What about this one? FE, EH, FG and GH. Okay, no problem. Okay, no problem. Now guys, you can see here, no doubt FE will contain certain force. Similarly, EH will also contain certain force. Then we have FG and GH. These two member will also have certain force. Why? Because this joint G is free to move in the horizontal direction as well as in the vertical direction, right? So due to that reason, you may find certain forces there in member FG and GH. So that's why guys, our option is A. A is the correct answer for this particular question. Clear? Clear? And let us suppose guys, if it is MSQ, then you can tick B option also or C option also, right? Then you can tick B option also and B and A option both, right? But right now it is MCQ, so that's why we are trying to tick only single answer, that is basically A. Next, again you need to find out zero force member. Very simple. 0. Okay. This one is also 0. Okay, sir. Next one is basically this member is 0, this member is 0. Okay, done. Remove this, remove this. Consider this particular member, it is also 0 because at this particular joint 3 members are meeting. This one is also 0 and this one is also 0. Next, if you remove this particular member, this 10 kilonewton load is applied like this. So this member will become 0. And if it is 0, then this member is also 0 force member. Perfect. What about this one? What about this one? What about this one? If we remove this particular member, now only 2 members are present, 1 and 2. Both are non-collinear in nature. We can make it 0. Done. If this one is 0, this one is also 0. If this one is 0, this one is also 0. Okay, sir. Any other member which we can make as a 0 force? Any other member? Any other member, guys? If 10 kilonewton load is applied like this, so this is also 10. This is also 10. What about this member? No doubt it may contain certain force. This one is also having some force. This one is also having certain force. So let's count how many 0 force members are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12 members are there which contain 0 force. 3, 2, 5, 5 plus 7, 12. Total 12 number of members are there which contain 0 force basically. Next question. Next question. A truss is shown in the figure. Members are of equal cross-section area A, same modulus of elasticity E. A vertical force P is applied at point C. Force in the member AB. This one is AB. AB of the trusses. You need to just find out what is the value of force in AB. I think we have already done this particular question in the yesterday class. This particular problem we have already done it, right? So kindly check the previous class. You may find the same question was there. Next one. Now this is a MSQ type of problem. You need to choose the correct statement. Which of the following statements are correct over here? Okay, let's do it. Choose the correct statement. Choose the correct statement. Only 5 members are 0 force member. Okay, let's find out how many 0 force members are there. 0, perfect. 0, perfect. This one is 0, done. Then next is this particular joint, not possible. This joint is not possible. This joint is not possible. This one is also 0, perfect. If you remove this member, then this member will also have 0 force, perfect. At this joint, not possible. At this joint, not possible. So guys, only 5 members are 0 force member. Are you able to see this? In this particular truss, how many members are 0 force member? This one is 0. Let us consider this particular joint. Not possible. This joint, vertical member is 0. If you consider this joint, you have 1, 2, 3, 4, 5 member. Not possible. 4 member, not possible. 4 member, not possible. Loading is given, not possible. Multiple members are there, not possible. 3 members are there, 2 collinear, 1 non-collinear, make it 0. Not, wait a minute. We will consider this particular joint first. Not possible. This one, yes. Vertical will be 0. At this particular joint, yes, this one is 0. If you remove this, you may have 2 collinear, 1 non-collinear, make it 0. Done. If you consider this particular joint, now you are having 3 member out of, means total 5 member, out of which 2 are 0 and 2 are collinear, 1 is non-collinear. But you have 1 external loading. That's why this is non-zero. Okay, sir. So only 5 members are there which have 0 force. Okay. Next. If we remove 0 force member, then structure will become stable. No, guys. Such statement is wrong. The requirement of a truss member is basically it will take certain force as well as it will take part in the stability of the structure. If it is not taking force, it doesn't mean that you have to remove it from the structure, right? Still, it is required to maintain the stability of structure, mainly internal stability, right? So guys, B statement is wrong, because as per this statement, if we remove the zero force member, then structure will become stable, which is wrong. Zero force member is also required for stability of structure. Yes. 4 member are zero force member. No. So only A and C is the correct option. A and C are correct. A and C are the correct answer. Clear? Perfect. Next question. Next question. Find out the zero force member. Find out the zero force member. Find out the zero force member and the reaction force. Length of each member is basically length of horizontal member is basically 4 meter. Length of horizontal member is 4 meter. Now you know that, guys, this vertical reaction VA should be 180 kilonewton, and this vertical reaction VE is also 180 kilonewton. That means VA and VE is 180. And what about HE? HE is 0, we know that, right? HE is already 0, and due to this, HA is also 0. So B is 100% correct. B is 100% correct. Now what about how many zero force members are there? So if you consider joint J, this one is 0, this one is 0. If you consider joint F, this one is 0, this one is 0. Clear? If you consider joint C, this one is 0. Clear? This one is 0. Now right now how many member you have? Zero force? 5. Okay, sir. But guys, let me show you some other member also, which is hidden right now. If you take a section like this, if you take a section like this, okay, if you take a section like this, then again you may find there is one more member which is having certain, means zero force basically. Let me show you that. This is 180, and 180 is also applied at this particular joint in the downward direction. Let us consider this member is FBH, and this angle is theta. Clear? Now guys, if you write summation Fy is equal to 0, if summation Fy is equal to 0, that means 180 in upward direction minus 180 in downward direction plus FBH sin theta is equal to how much? 0. So you can cancel these two values, and ultimately FBH will become 0. Yes or no? Yes, sir. If FBH is 0, if this member is 0, then this member is also 0 force, right? You can solve it. So ultimately 7 members are there which is having 0 force, and that's why D is the correct answer as well as B is the correct answer for this particular question. Let's move to the next one. For the truss shown in the figure, the magnitude of force in SR member, you need to find out what is the value of force in this particular member SR. What is the force in this particular member SR? What is this particular force? Can we calculate it? Okay, let's do it, guys. Let us consider, and I think this is the last question. Yes, this is the last question of the class. So guys, let us consider this is our VP reaction, this one is VQ, then we have HP reaction. Clear? Now what we will do, guys, we will take summation moment about P is equal to 0, so that we can get the value of VQ. Or let us calculate the value of VPR. So summation moment about Q is equal to 0. So we can write here VP into how much? 1 plus 1, 2, clockwise. then HP will not produce any kind of moment about point T, okay, oh sorry, about point Q, okay. Then we have 30 VP into, sorry, VP into 3R. Why we are writing VP into 2? VP into 3, 1, 2, 3, VP into 3. Then minus 30 into 1 is equal to 0. So VP is equal to how much? 10 kilonewton. If VP is 10, then VQ is 20. Okay. Now guys, what we'll do, we'll try to take a section like this. We'll try to take a section like this. Okay. And consider this particular part of the structure. So this one is FSR. What about this one? FTR. What about this one? FTQ. Okay. Now what I will do guys, I will try to take moment about point T is equal to 0. Okay sir. So let us write down summation moment about point T is equal to 0. So VP into this distance, which is basically 2 meter. Then HP will not produce any kind of moment, as well as the value of HP is 0. Okay. Next is 30. 30 is again not producing any moment, but FSR multiply by this vertical height, again 1 meter, which is equal to 0. Okay. What about VP? VP is how much? VP is basically 10. Okay sir. So FSR is equal to how much? It is minus 20 kilonewton. That means it is compressive in nature, nothing else. So answer should be C. C is the correct answer for this particular problem. Crystal clear? So guys, just a quick recap or quick summary of this particular session. We have discussed 3 concepts for the zero force member. First one is where we have a particular joint where 2 members are meeting, and at that particular joint we don't have any kind of external load or external support reaction, and both the member are non-collinear because theta is in between 0 to 180 degree. In such condition, both the member is zero force member. Second concept which we have discussed is basically, let us suppose if there are 3 member which is meeting at a joint where 2 member are collinear, one is non-collinear, right? Again, no external support reaction, no external loading is present at that particular joint. In such condition, non-collinear member will have zero force and other 2 member will have equal and like forces. That means same magnitude and same nature. Third concept, if you have a member which is constrained by the support reaction and there is net change in length of the truss member is 0, in such condition that member will also have zero force. So these are the 3 concepts which we have discussed in our today class, as well as we have discussed the question part also. Okay. Okay guys, so this is the quick 2-minute summary for this particular session. Again, you will get my PDF, means PDF for this particular session as well as the lecture link by using this particular Telegram link guys. Okay, so this is all about for today. So thank you so much guys for joining the session, and let's meet in the next one. We'll discuss the further thing in tomorrow class. Okay, bye bye guys, take care, and thank you so much for joining it.